This is 2.5, Day 1, Graphing Rational Functions. So all of this should be a little familiar to you from Algebra 2. Maybe you kept your notes from last year, but it should be similar to it. The steps for graphing rational functions. First, number 1, you need to factor the numerator and the denominator. 2, if a factor in the numerator and the denominator cancel, it's called a hole or a point of discontinuity. I think your book calls it a hole, but other books and your calculus book might call it a point of discontinuity. So you're going to set the canceled term equal to 0. So like for example, if x plus 3 is in the numerator and x plus 3 is in the denominator, you'll set x plus 3 equal to 0 to get the x part of the whole, and then to get the y part of the whole, you substitute it back. You substitute the x value of the whole back into what's left in the fraction. So after the x plus 3's, for example, are canceled out, you plug it into what's left. You'll have examples of this on the next screen. So you might want to pause me while you write all this down. 3, we're going to find x-intercepts. In a fraction, to find an x-intercept, normally you would set the y equal to 0. However, since we have a fraction, the only thing that's going to matter is that your numerator equals 0. So you're going to set your numerator equal to 0 and solve for x. You're going to write the intercept as a coordinate. And it needs to be written as a coordinate. If you just write your x-intercept as x equals whatever, I'm going to mark it wrong. Intercepts are points. I want them written as points, regardless of if your book writes it that way or not. I don't know if your book does or not. I haven't looked, but I want them written as coordinates. Y-intercepts, you're going to substitute 0 for the x in the factored form and reduce the equation and solve for y. Again, you're going to write this as a coordinate, 0, comma y, and again, I will mark it wrong if you just say y equals whatever. Because when you say x equals something and y equals something, you're talking about vertical lines, which is my next step. You're going to find vertical asymptotes. And a vertical asymptote basically means that there is a value that your graph can't have. So at the beginning of this semester, when we went over domains, you looked at places where your graph would approach but not cross. So you're going to set your denominator equal to 0, and it needs to be written in the form of x equals something or other, so that you're showing that it's a vertical line that your graph approaches but doesn't cross. Horizontal asymptotes. There's various ways to do this. Your book does it slightly different. The easiest way is to identify the degree of the largest variable. You're going to take the coefficients of that variable in the numerator and the denominator, and you're going to write them as a fraction. And they need to be written in the form of y equals. Hold on. I need to, give me a second. Okay, in the form of, there, so you can see it. So they need to be written in the form of y equals. So you might want to pause this and write it all down. 7, you are going to find oblique asymptotes. Sometimes you will see them referred to as slant asymptotes. They occur when the degree of your numerator is higher than the degree of your denominator. You can also tell that you have one if you don't have a horizontal asymptote. So your oblique and your horizontal don't occur at the same time. And to find that, you're going to use synthetic or long division to find the equation of the asymptote. However, you don't use the remainder. The reason you don't use the remainder, and you'll find this out in calculus, is because that particular part, that remainder, which is, say for example, 7 over x minus 3, basically adds a very, very little bit to your graph, and it does not have an effect on your graph. It has to do with limits, and you'll do those at the end of the year. So you're not going to use the remainder. A couple things to keep in mind. You're not going to have a horizontal and oblique at the same time, and your graphs can cross a horizontal, and they actually can cross an oblique asymptote. So keep that in mind. They will not cross a vertical, but they can cross a horizontal and an oblique. Okay, let's look at example 1. F of x equals x plus 4 over x minus 3. First thing we're going to do is we're going to find a hole. So to find your hole, first thing you're going to do is you're going to factor. And since there's nothing to factor, a hole you get by seeing if anything cancels out. This x does not cancel out. Be careful of that. These are basically individual terms. And so there's no hole because nothing cancels out. My y-intercept you are going to get by plugging in 0 for your x. That gives me 4 over negative 3. So my y-intercept is 0, negative 4/3. My x-intercept you get by setting your numerator equal to 0 and writing it as a coordinate. So my x-intercept is negative 4, 0. So let me plot these before we go any further on my graph. And when you do these graphs at home, you need to be doing them on graph paper. If you do them on anything else other than graph paper, I will mark them wrong. So you need to have an x-intercept at negative 4, your y-intercept at 0, negative 1/3, and I'm going to try to do the best I can because I'm using my finger trying to draw it. Then vertical asymptote, let me change colors. Okay, for a vertical asymptote, you need to set the denominator equal to 0. So x minus 3 equals 0. My x is 3. And they are equations of lines. So you're going to draw a line at x equals 3. Okay. Then my horizontal asymptote. You are going to take a look at your original equation and you're going to find the largest variable. And by largest variable, I mean the x with the largest degree. And you're going to take their coefficients. So my largest degree here is x. So my coefficient for x in the numerator is 1. My coefficient for x in the denominator is 1. So here, let me change colors again. Let's try purple this time. Okay. So here, your largest variable is x. So my coefficient in the numerator is 1. Coefficient and denominator is 1. So 1 divided by 1 is 1. So that's y equals 1. So you have a horizontal line at 1. Then, if you have a horizontal, let me find yellow, you are not going to have an oblique. So right now, to graph this, let me go back to a pink. I can already, let's see how well I can do this on the screen. You're going to have a graph over here. Actually, let me make this thicker. Okay. And then the other one up here in this area up here, I'm going to have to pick an x value because I need to see whether it's going to be up in the top right-hand corner or if it's going to be down here in the bottom right-hand corner. It needs to come close to the asymptote but not go through it right now. So I'm going to try, for example, 4 in my equation and see what I get. Let me pick, let's do white. So if I plug in 4, 4 plus 4 over 4 minus 3, that's 8 over 1. So I'm going to get, okay, maybe that wasn't the best color. I'm going to get 4, 8. It's up here. So now the other part of my graph is going to be in this area in here. And that is my graph for that rational function.